First assignment. Not yet. Week six, week six, week six.
Week six.
Yeah, right before the Christmas.
What week is this?
21st or 20.
The second week, no? No, third.
Now it's the third.
Third week, right?
Yeah, third week.
What do you address up to class?
Hi everyone. Can you hear me? Can you hear me, all our students?
Yep, can hear you, mate.
Okay, thank you. So last week we stopped at pressure variation. Do you have any question about tutorial last week? Pressure variation. Pressure variation is mean. Let me show you. What's do you have any question about pressure variation? Oh, why can't I? Let me see. What's the problem? Excuse me, do you have any question? Okay. So what we did last week, pressure variation. Yeah, this one. Pressure variation is mean when you go up, pressure decrease, and you go down, pressure increase. Okay, and pressure if you at the same level, the pressure is constant. Same level is mean, for example, now you at UTS or at Central Station or in Japan, the same pressure is the same level, same pressure is the same. Pressure only change in if you go up or down. Okay, and you have the equation is dp over dz equal to minus rho z, or dp over ds equal to rho z. It depends on the axis. Z direction is upward and s direction downward. Okay, and if the density is constant, you can use two equation here: pz minus po equal to minus rho zz, or ps minus po equal to rho zs, which po is pressure at z is 0 or s is 0. Okay, this on the pressure variation. And last week we worked in this question. Yep, this is the question last week. You have to find the water level D. You have to find D. Okay, for the situation, this situation. And the process, if you want to find D, you have, because D is the distance between point C and point B. So to find D, you have to know PC and PB. Okay. To find PB, you have to know PA, because the distance between B and A is L is 12 meters, you know. Okay. And PA will be equal to atmospheric pressure. And atmospheric pressure, you can use is 101.3 kPa absolute or 0 gauge pressure. Okay. And PC, because between C and D, we have air, and the pressure change in the air is very small. So PC, you can estimate PC equal to PD, okay? And PD you can find from, if you know PE, because you know the distance between D and E is S is 0.7 meter, okay? And PE is atmospheric pressure, okay? So from this one, you can find D, okay? As a result, you have on the tutorial 2 on UTS Online. Okay, this one, question 1 about pressure variation. And this week we will continue with pressure variation, tutorial 2. Okay, tutorial 2. This one is our question last week. And this week we will start with this one, question 3. This question is similar to question 1, this question. Okay. And question 3. This one. You have a system as shown in the screen. So a sectional view through a submarine. And we have atmospheric pressure is 10 kPa. Okay, and sea water density is 1020 kilogram per meter cube. You have to find the depth of the submarine Y. Okay, you have to find Y. It's similar to our question last week, with atmospheric pressure is 101 kPa. Okay. In this question, the atmospheric pressure we use is absolute pressure, and it's 101 kPa. So all pressure in this system we use absolute, not Gauge. Okay, because this one is absolute pressure. And water density of seawater is 1020 kilogram meter cube. Okay, you have to find Y. Similar to our question last week. How to find Y? I call this one point is point A. This point is point B. This point C. Point D. Point E. And point F. Okay. A, B, C, D, E, F. You have to find Y. Y is the distance between A and B. Okay. So similar to previous question, this one. This one. Okay. In this question, to find D, you have to know PB and PC. Okay, you have to know PB and PC. So for this one, to find Y, you have to know PA and PB. If you know PA and PB, you can find Y. Okay, because you have PB minus PA equal to rho Z Y. Okay, based on the pressure variation equation. PA at the water surface will be equal to atmospheric pressure, or 101,000 Pascal. Converts to SI unit. SI unit is Pascal, not kilopascal. Okay, SI unit. You have to convert to SI unit before any calculation. Okay. PB. Okay, to find PB, you have to know PC, because the distance between B and C you know. Okay, you know the distance between B and C. So if you know PC, you can find PB. To find PC, you have to know PD, because the distance between C and D you know. And between C and D you know is mercury, Hg. Okay. PD, how to find PD? How about PD? How about PD? How to find PD? PE. PD will be equal to PE, because between D and E is air. So pressure change in the air is very small. Okay, so pressure D will be equal to pressure E. Pressure E. And how to find pressure E? You can find pressure E if you know pressure F, PF. And how about PF? How to find PF? How to find PF? In the previous question, this one, Okay. To find pressure B, you find pressure C. Pressure C equal to pressure D. You can find pressure D if you know pressure E. And pressure E is equal to atmospheric pressure, because in here we have is open area and the air can flow in this tube. So here we have atmospheric pressure. But in this question, this one is a closed. So how about pressure F, PF? Yeah, this point. How about PF? If this tube is open, the pressure F will be equal to air pressure inside the submarine. Okay. If this one is open, PF will be equal to air pressure inside the submarine. But this one is closed. The barometer is closed on top. Okay. So how about pressure F? PF in this case. How about PF in this case? How about PF? Do you have any idea to find PF? PF in this case. How to find PF? PF in this case, PF will be equal to vapor pressure of mercury. It means point F, mercury boil. And why PF equal to vapor pressure? We come back to one experiment I show you in the lecture slide. This one is week 1. This one experiment. This one. Okay. This one. When you have a tube and this one is open end, this one is closed end, and open end you dip on the water and you bring to a closed end to higher than 10 meters. Okay, on the top of the tube you will have vapor. You have vapor on the top because the pressure at the top equal to vapor pressure of water. Okay, I will repeat a little bit about this experiment because I think some of you forgot this one. Yeah, we have a long tube. Yeah, this one is point A, this one is point B, and this one is point C. Okay, A, B, and C. C on the top of the tube. Okay, so for this one, you will have PA equal to PB equal to atmospheric pressure, or 101,300 Pascal. Okay, 101,300 Pascal. Point C, between B and C, we have the water, and C above B, so pressure C will be smaller than pressure B. So PB minus PC will be equal to rho water Z, and this one is H. Okay, rho ZS. Or you have PC will be equal to PB minus rho water Z S. Okay, with PB here is atmospheric pressure 101,300 Pascal, row of water is 1000 kilogram per meter cube. This is 9.81. Okay, so you see PC will be smaller than PB. Go up, pressure decrease until pressure C equal to vapor pressure. For example, you have 15 Celsius of water at 15 Celsius. And this one you can double check in the table. So the table in here in vapor pressure of water. Yeah, at 15 Celsius, you have vapor pressure of water is 1.7 kilopascal. Okay, 1.7 kPa. It means we go up, pressure decrease, and until pressure C is 1.7 kPa. Water boil at 15 Celsius. Okay, when we have this pressure 1.7 kPa on the top, water boil at just only 15 Celsius. And because water boil, so on the top here we have vapor. Okay, and if you apply PC is 1.7 kPa in this equation, you can find S is approximately 10 meter. It means up to more than 10 meter, you will have a C water boil. Okay, that's why in this experiment, in this experiment here, okay, we have the distance. This distance from the water surface to point C here is more than 10 meter. Yeah, water boil at only 15 degree. If you can create a pressure is 1.7 kPa. Okay, water boil at only 15 Celsius. Yeah, based on this table. Okay, in the normal condition, 101.3 kPa, water boil at 100 Celsius. Okay, but if you can decrease the pressure to only 1.7 kPa, water boil at only 15 Celsius. 1.7 kPa. Okay. So this one is similar to our question. This one. Okay. Pressure at E, we have pressure at E, and in here we have mercury. And when we go up, pressure decrease until pressure F equal to vapor pressure of mercury. We will have empty space on the top of the barometer. Okay, on the top of barometer we are not empty. We have mercury, but in vapor. Okay, so pressure F will be equal to vapor pressure of mercury. And vapor pressure of mercury you have from this table. Mercury, okay, vapor pressure here. It means PF will be is 1.6 E minus 1 Pascal or 0.16. Okay. So pressure F will be equal to 0.16 Pascal. It's very small pressure. Okay, 0.16 Pascal. Okay, so now you can find Y with PF equal to vapor pressure of mercury, or 0.16 Pascal. Okay, 0.16 Pascal. And now when you have PF, you can find PE. From PE, you find PD. From PD, you have find PC. And from PC, you find PB. Okay. And from atmospheric pressure, you find PI. And Y you have from the difference between PI and PB. Okay. So we will start from PF. We have PF is vapor pressure of mercury of 0.16. Okay. 0.16 Pascal. Now from F you find E. E below F. So PE minus PF equal to rho between E and F, mercury. So rho is the rho of mercury. Okay. Times Z times the distance between E and F. The distance between E and F is 840 millimeter. And we have to convert to meter, SI unit. So this one is 0.84 meter. Okay, the distance between E and F. Density of mercury, you have from the table. Density of mercury is 13,600. Okay, it's 13600 kilogram per meter cube. Okay, so be careful. Between E and F, we have mercury, not water. Density of water, just only one. Seawater, just only 1,020. But density of mercury is 13,600 kilogram meter cube. It's very high compared with the density of water. Okay, so remember that between E and F, mercury, Hg, not water. And Z is 9.81 gravity. Okay, PF here. Okay, so from this equation you can find PE. PE equal to PD, because PE equal to PD equal to air pressure inside the submarine. PE will be equal to PD and equal to air pressure inside the submarine. Okay, equal to air pressure inside the submarine here. Equal to air pressure inside here, because this one is open and this one's open, and air can flow in here and air can flow in here. So pressure D equal to pressure E equal to air pressure inside the submarine. And now when you have pressure D, F got it, E you got it, D you got it. From pressure D you find pressure C. C below D. C below D. So you will have PC minus PD equal to rho GS C and D, mercury. Okay, so rho of mercury Z, and the distance between C and D is 200 is 400 millimeter, or 0.4. Okay, with this density you got here is 13600 kilogram meter cube. Z is 9.81. Okay, and PD here. So from this equation you can find PC. Okay, you can find PC. So PC you have, from PC you find PB. Okay, PC and PB. So between B and C, C below B. So you will have PC minus PB equal to rho. Now between B and C is water, seawater, not mercury. You see the blue color here. So this one is density of water times Z times the distance between B and C is 200 millimeter, or 0.2 meter. Okay. And density of water, seawater in this question, we have 1020 kilogram meter cube. Yeah, this one. 1020 kilogram meter cube water density. C is 9.81. Okay. And PC from this one. Okay. So from this equation, you have PB. Okay, got it? Now you have to find PI. But PI equal to atmospheric pressure. Okay. PI equal to atmospheric pressure, or 101,000 Pascal. Pascal is absolute pressure. We have to use absolute pressure because PF equal to vapor pressure. This pressure is absolute pressure. All pressure you see in the table is absolute pressure, not gauge pressure. Okay, so this one is absolute pressure. So atmospheric pressure, we have to use absolute pressure, not gauge pressure. Okay. So when you have PI and PB, you can find Y. Y is the distance between A and B, and B below A. So you will have PB minus PA equal to rho of water Z and Y. Okay, between A and B we have water. So from this one you can have Y equal to PB minus PA divided by density of water times Z. With PB you have here PA, yeah, density of seawater 12020 kilogram meter cube, and Z is 9.61. So you can find Y. Okay, this one is pressure variation. Okay, so but for this question, remember that if you have closed area like PF, the pressure on the water surface will be equal to vapor pressure. Okay, if it's we have open area, the pressure equal to atmospheric pressure. Okay, this one is a difference between this question and the question last week. Do you have any question? Online student, do you have any question for me? No? Okay, thank you. So here we have two questions with the density is constant. Use let me see, not this one. Here, pressure variation. If the density constant, we can use Pz equal to PO equal to minus rho Gz, or PS minus PO equal to rho Gs. We have two questions about this one. One last week and one we have to do it. We did it already. And now I will give you one question about this one. The original equation when the density is not constant. So we have to use dP over dz equal to minus rho z, or dP over dx equal to rho z. Okay. This question is a question, yeah, question 3 and 4 in the tutorial 2. Okay, so we will work out with question 2 and question 4. You can try to read by yourself. Okay, and actually the solution, all solution you have on this document already. Yeah, the solution. Okay, so we will work with question 2 when the density is not constant. Okay, question 2. This one. In the question 2, you have to find the weight density gamma equal to rho z. Okay. Weight density equal to density times gravity. Okay. Of water in the ocean may be calculated from this relation. Gamma equal to gamma rho plus Ks1 divided by 2. Okay. It means in this case, the weight density depends on the depth h, depends on h. H is the depth below the ocean surface. Okay. The weight density is not constant, depends on the depth, or the density not constant, depend on the depth. So you can't use the Pz equal to Po equal to rho Zs. Okay, you have to use P dP over ds equal to rho z. Okay. Weight density or density depends on the depth, not constant. Okay, h is the depth below the ocean surface, k is constant, and gamma O is the weight density at the ocean surface. We write an expression for the pressure at any depth h in the term of gamma O, h, and k. Okay, you have to calculate the weight density and pressure at a depth 3.22 kilometer, assuming gamma 0 is this one. The weight density at the ocean surface is this one, s in meter, and k is this one. Okay. For this question, you have this one is ocean surface. This one is state O. Okay. And below 3.22 kilometer is this distance is h. We call it s. And this one is state h. This one is PO. This one is PS. Okay. And you have to find the weight density and the pressure at the depth 3.22 kilometer. If we have the weight density gamma equal to density times gravity. Okay, and the gamma will be equal to gamma O is at the water surface plus K S1 divided by 2. Okay, with S the depth, K is constant, and gamma O is the weight density at the ocean surface. Gamma O we have is 10 kilonewton per meter cube, and K we have is 7.08 Newton per meter power 7 divided by 2. Okay. And the question is, you have to find the weight density and the pressure at the depth 3.22. You have to find gamma S and pressure at S. Okay. You have to find the weight density at the depth H and the pressure at H, PS and gamma H. PS and gamma S, PO and gamma O here. Okay, this is the question 2. So you see in this question, the density or the weight density is not constant. Density and weight density depends on S. Okay, so as I said, when the density is not constant, okay, density is not constant, you have to use equation 1. Okay, dP over dz equal to minus rho z, or dP over ds equal to rho z, when density is not constant. Okay. So in here we have 2 questions. Weight density and pressure, and which one we can find first? You can find the weight density first or pressure first? Pressure. Why? Why weight density? Because we have equation already. The weight density, yeah. Weight density with S. Yeah, the density. You can find the density first. One online student says weight density first because weight density. Because we have weight density at S will be equal to weight density gamma O plus K S1 divided by 2. Yeah. Yep. With weight density, as a water ocean surface is you have is 10 kilonewton per meter cube. Okay, and this one is not SI unit. Kilonewton is not SI unit. So you have to convert to Newton per meter cube. Is 10,000. Convert to Newton per meter cube. K you have is 7.08 Newton per meter power 7 divided by 2. And S 3.22 kilometer, 3220 meter. You have to convert to SI unit. Okay, SI unit. Okay, so in here you will have the weight density is around, let me see, the result is around 10,000 for 100 newtons per meter cube. 10,400 newton per meter cube. A little bit higher than the weight density at the ocean surface. Okay, it's not constant. At the ocean surface, the weight density is 10,000. Okay, and at the deep 3.22 kilometer, weight density is 10,400 newton per meter cube. So if you have this question on the quiz, one question, 1 mark. That's easy. Yeah. For the quiz you will have 10 questions. One question, 1 mark. Yeah. 80 minutes. No, yeah, final exam 2 hours. 10 questions, 80 minutes. Yeah. It's easy. One question, it's easy. But actually, maybe the I will talk about the quiz on week 5 right before the quiz on week 6. But and I will give you the where we will give you some topic. Yeah, closer with the quiz closer. No, not yet, but try to give you as soon as possible, as much as possible. Yeah. Okay. Weight density you have and pressure. dP. Okay, yeah, not dP over dt. dP over dz. The equation of the pressure is not dP over dt equal to minus rho z. The equation here. dP over dz equal to minus rho z. And z, you see z, oh sorry. And z here, upward, it depends on the axis you use in this case. Z upward. If Z upward, dP over dz equal to minus rho z. S downward. If you use S direction, dP over ds equal to rho z. Okay, because as you know, when we go up, pressure decrease, and we go down, pressure increase. Okay, so depends on Z or S, you will have the difference. equation. Thank you for the question. Okay, so now you have to find pressure. If density is constant, PS equal to minus PO equal to rho GS, that's easy. Okay, but in this case, density is not constant. So we have to use the original equation is dP over ds equal to rho z. We use S direction here, downward. The diff, S is a diff. Okay, dP over ds equal to rho z. This one is the equation. And rho z is gamma. Is gamma or weight density. So you have dP over ds equal to gamma. And you have to find the pressure from this equation. Okay. And gamma, you have here equation is gamma plus K S1 divided by 2. Gamma. Okay. So you will have dP equal to gamma O plus K S1 divided by 2. Yes. Okay. So integral from O to S of dP, sorry, PO to PS of dP will be equal to integral from O to S of gamma O K S1 divided by 2 ds mathematics. Okay. So from this one, you will have PS minus PO equal to, when you move this one out of integral, you will have gamma O S plus K S power 3 divided by 2 divided by 3 divided by 2 from O to S. Okay, or you have PS minus PO equal to gamma O S plus K S 3 divided by 2 divided by 3 divided by 2, because at S is 0, gamma O times S is 0 and K times S is 0. So you will have the new equation to find pressure if the density is not constant. Okay, PS is equal to PO equal to gamma O times S plus KS power 3 divided by 2 divided by 3 divided by 2. Okay, so you will have PS equal to PO gamma O S plus K S 3 divided by 2 divided by 3 divided by 2. With pressure PO here at the water surface, so PO you can use is 0 gauge pressure, atmospheric pressure, and 0 kPa gauge pressure. Okay, so this one is 0. Gamma you have is 10,000. S is the 3220 meter. K you have here is 7.08. 7.08. Okay. S is 3220 meter. So from this one you can find pressure at H is around 33100 kilopascal. This one is gauge pressure. Gauge pressure. Okay. So from this question, you only remember that if pressure, sorry, if density is not constant, you have to use dP over ds is equal to rho z. Okay, dP over ds equal to rho z. You can't use ps minus pl equal to rho zs. Okay, the new equation will be is ps minus pl equal to rho zs plus k s power 3 divided by 2 divided by 3 divided by 2. Okay, you have the new equation to find pressure if the density is not constant. Okay. Do you have any question? Any question? And in the tutorial 2, we have one more question about density not constant. It's question 4. Yeah. In question 4, we have in the diabatic model of the atmosphere. Okay. In addition to the ideal gas equation, as is also assumed to obey the equation, we have this one. When n is 1/4, if the condition at sea level as standard, you have to find the pressure and the temperature at an altitude of 4,000 meters above the sea level. Okay, because this question asks you the pressure and temperature at 4,000 meter altitudes. Okay, it's not at the sea level. At 4,000 meter altitude, if you have a look in the table, when we go up, the density decrease. So it means the density is not constant. Density at sea level and 4,000 meter altitude is different. Density is not constant, so you have to use dP over dz equal to minus rho z, or dP over ds equal to rho z. Okay, it's similar to the question 3 as a question 2 here. And the solution here, you have the very detail in here. You use dP over dz equal to minus rho z. Okay. And from the equation, you can find pressure, mathematics, math. Okay. Okay. So, yeah, let me see one question. The density, rho is the density, and gamma is weight density. Weight density equal to density times gravity, rho z. Okay, here. Yeah. Rho is the density, okay, and the weight density gamma equal to rho z. Any question? No. So please try to do the question 4 by yourself, okay? And as a solution, you can find at the end of this document. And if you have any question about this question, you can email me, okay? So now we will move to another topic. The most important topic in fluid statics is force on surface. We have plane surface and curved surface. Okay, and as I said in the lecture yesterday, you in the quiz you have 10 marks and a half, 5 marks will focus on force on surface. The force on surface is the most important thing in fluid statics, part 1 of the fluid mechanics. Okay, so before coming to the first question about the force, we will summarize a little bit about the force on plane surface. Force on plane surface. Force on plane surface, for example, we have a surface AB. You have AB under the water surface. This one is PO is 0 K. Okay. when we have a surface AB under the waters, we will have a force applied to this one. And the force, as I said yesterday, to understand about one force, we have to know three things. One is the direction. Second one is the magnitude. And the last one is the position. Position. Three things you have to know to understand about one force. Okay. So AB under the water surface. So we have pressure applied to this one. When we have pressure, we have force applied to AB. Okay. And this force in direction, about the direction, will be in perpendicular and onto the surface AB. Okay, in perpendicular. About the magnitude, we know that pressure, force will be equal to pressure times area. Okay, and pressure in this case, for example, on the liquid, pressure will be equal pressure C, which C is the centroid of AB. Okay, so magnitude force will equal to pressure times area, which pressure is pressure at C. Okay, and pressure C, you can find pressure C based on pressure O or on water surface. Okay. About the position, the force will apply to CP. CP is the central pressure, a little bit below C. This one is force. Force applied to CP, not C, because when we go down, pressure increase. So pressure at A will be higher than pressure at B. So F at A will be higher than F at B. So the total force in the whole surface will be a little bit below the centroid C. Okay, so this force will apply to CP. And the distance between C and CP, we call is delta CP. And delta CP will be equal to IC, the second moment of the area, divided by LC times area. Okay, IC is the second moment of area or second moment of inertia you have from the table. Yeah, this one. Okay, IC. For example, with a rectangle, you have IC equal to 1/12, B A power 3. This B is this one, this side, and A is this side. Okay, so IC for the some shape, common shape, you have is the cosine. IC you have in the figure equation. A is the area, is okay, and LC is the distance from C to pressure is 0 G, and in AB direction, this one is LC. The distance from C to pressure is 0 G in AB direction. Okay, is LC. So we have three things. We have to find about force, is the direction, magnitude, and position. Okay, three things. So we will apply this one to this question. This one is question in tutorial 3. Okay, tutorial 3. Tutorial 3. This one. Okay. Question 2 in tutorial 3. Force on plane surface. Okay. Do you have any question? about how to find the force on plane surface. This one. Do you have any question? This one is what we studied yesterday. Okay, direction in perpendicular with the surface AB. Magnitude force will be equal to pressure time area and position. Force will apply to CP. CP is the central pressure. And the distance between CP and centroid of AB is delta CP equal to IC divided by LC time area. Okay. The first question about force on plane surface. You have a word OAB of the water container. So is pivoted about O. You have O here. You have to determine the moment about O. Due to the force of water on this word. Force of water on word OAB. With the container is 4 meters long in the direction into the space. It means if you see in 3D, this square will be into the space 4 meters. 4 meters into the space. Other dimension is S is 2 meters. B and C is 1 meter. 1 meter. You have to find moment about O. Moment about O due to the force of water on the wall OAB. Okay. Wall OAB. Now how to find moment. How to find the moment. Yesterday we have a question about moment already. Here is this one. Yesterday. Which one? Let me see. This one. Okay, this one is a question yesterday. This is question in quiz autumn semester 2018. Okay. And we have moment, the last question. Moment equal to force times the distance from the force to the pivot AB. Okay. So in this one, you have to find the moment. Sorry. Moment due to moment about O due to the force of water on the wall OAB. You have wall OAB. So in this way, it's up to you. You have two ways to give solution in this case. First one, you can assume OAB is one wall. And second one, you can divide to two walls, OA and AB. Okay, and you have the force applied to OA and force applied to AB. Okay, and the moment will be equal to moment by the force applied to AB and the moment on OA. Okay, moment will be equal to moment by the force applied to AB and force applied to OA. And moment AB will be equal to force applied to AB times the distance from O to the FAB. Okay, moment OA will be equal to force applied to OA times the distance from O to this force. Okay, this one is fundamental. Okay, moment applied to OAB will be equal to moment applied to AB plus moment applied to OA. Okay, and moment will be equal to force times the distance from O to the force. So the key here is you have to find the force applied to wall OA and wall AB. Okay. So first we will work together in FAB. and you can try to find force supply to OA. Okay, AB and OA is similar. AB, A, B, and this one is O. Okay, you have to find the force applied to AB, FAB. And as I said, to understand about one force, you have to know three things: direction, magnitude, and position. Three things to find the force applied to AB. Direction in perpendicular with AB. With AB. Okay. Magnitude, pressure, sorry, force, force applied to AB equal to pressure. Pressure applied to C, C is the centroid of AB, PC times area AB. Okay, force equal to pressure times area. With area AB, we have AB is 2 meters, and this wall into the page is 4 meters long. So area AB will be equal to 2 times 4, or 8 meters square. Okay, AB is 2 meters. This one is 2 meters, and into the page is 4 meters. Okay, so this wall is 2 times 4. PC. How to find PC? How to find PC? Pressure C. Yeah, rho GS, pressure variation. Okay, so PC will be equal to PO. This one is PO. On the water surface plus, what's the problem? PO plus rho Z S, which S is a distance, is BC. Okay, so plus rho of water times Z times BC, rho ZS. Okay, with PO is 0 gauge, 0 Pascal. This one is gauge pressure. 0 Pascal, gauge pressure. Rho of water 1000. Okay, Z 9.81, and BC. BI is 2 meters, so BC is 1 meter. So you can find pressure C, rho GS, from pressure variation equation. Okay. BC equal to PL plus rho Z BC. BC is the distance between B and C. So magnitude is okay, and position. Position. So we know that force will be applied to, not applied to C, it's applied to CP, a little bit below C. This one is FAB. Okay, FAB will apply to CP. And the distance between C and CP is delta CP. Is delta CP. Okay. And to know the position of the force applied to AB, we have to know where is CP. To know where is CP, you have to know delta CP. And the delta CP equation equal to IC divided by LC times area AB. Okay, area AB. With area AB, you got it. Here is 8 meters square. Okay, 8 meters square. IC, you have equation. This one is a rectangle, AB. You have a rectangle. This AB. This one is A. This one is B. And this one is 4 meters long into the page. Okay. So we can apply the equation for the rectangle. This one. Okay. So IC will equal to 1/12 BA power 3. This one will be, this one is X direction. This one will be is B. This one will be is A. Based on the figure on the cost note. Okay. So IC in this case will be equal to 1/12 B. B is 4 A power 3. A is or AB is 2 power 3. Okay. So you have IC. Equation for this one is IC equal to 1/12 B A power 3. Second moment of area. Okay, the equation you have on here. And as I said yesterday, if you want to know why you have this equation, you can go to this document, week 4, why you have this one. Yeah. Second moment of area. Okay. How to have the equation you have on the cost note. For example, here it's for the rectangle. To have the equation is a long story. Okay. It's not easy. For example, for the circle, you have this one. And for the different area, you have here the equation to find the second moment of area. Okay, so you don't have to remember, and you don't have to know why you have the equation on the cost note. You got this one already. Okay, and if you have a complex surface, you can try to cut it into the simple or into the common shape here. You have 5 common shape. Okay, and you have a more complex one, you can cut into 5 common shape here. Okay, so IC you have LC. LC, as I said, is the distance from C to pressure is 0 G in AB direction. So LC in this case is in vertical. Just only in this case, LC is vertical because AB is vertical. Okay, so LC here will be is 1 meter. Okay, 1 meter. So from here you can find delta CP, or the distance between C and CP. Okay, between the C and CP. About the result, let me see. The result, we will have this one is 0.333 meter, 43 meter. Okay. So where for the force FAB, you know the direction, you know the magnitude, and you know the position. So what you have to find here is the moment due to FAB. So moment FAB, moment AB will be equal to FAB times the distance from O. What's that? The distance, sorry, the distance from O to FAB. Okay, one question. A and B. Okay. A and B. Yeah. This one is our rectangle. Okay. And you have the axis here and B. A. You let me see. Okay, this one is rectangle. Okay. And the parallel with axis is B and A is the other side. Okay. So we have the axis here. B is parallel with axis and A is this one. So the inertial equation you have is 1/12 BA power 3. Okay. Got it? It's based on the here. What do you have on the cost note? The common set. Yeah. Which one is A? Which one is B? Okay. Yeah, short side power 3. Yeah. A in this case is a short side and B is a long side. In this case, in this wall OAB, in this OAB. Only in this case. Only in this case. Okay. It depends on the shape. Okay, it depends on the shape. If the shape is you have AB is 4 and into the pace is just only 2 meter. So this guy will be is 1/12 of 2 times 4 power 3. Okay, depends on the shape. Okay. For example, if AB here is AB and this one's only 2 meter, 4 meter, X here. So IC will be equal to 1/12, 2. IC, if you have this one, IC will be equal to 1/12 times 2 times 4 power 3. It depends on the set. Okay. So this one. So this one. Just only this guy. And moment. So moment AB will equal to force applied to AB times the distance from O to FAB. Okay. O here. So the distance from O to FAB is this one. D from O to FAB. And D from O to FAB will be equal to C. Here we have 1 meter. C is 1 meter. Will be equal to 1 meter plus AC. Yeah, this one will be equal to 1 meter plus AC minus delta CP. Okay, AC minus CCP. Okay. So AC you have is 1 meter, delta CP here. So you can find moment by the force applied to AB. Okay, MAB. So you can find MAB. This one. So you can find MIB. And similar for OA. Similar for OA. Similar for OA. Okay. You can try to do it by yourself, OA. But here is the difference between OA and AB is at LC in the delta CP equation. Okay, because LC is the area direction in, for example, for AB in AB direction or vertical. But for OA or LC in OA direction. Okay, so LC will be not in vertical. Okay, see for example FOA OA. Okay, three things: direction, magnitude, position. Okay, three things: direction, perpendicular with OA. Magnitude F OA will be equal to pressure OA times area OA. Okay, area OA will be equal to OA times 4 meter long into the page. Okay, OA times 4. Pressure OA. Pressure OA. Pressure variation equation. Rho GH. With this one is PO is 0. And here is the C, centroid of OA. And this one is SC. Okay, will be equal to PO plus rho Z SC. Rho Z S SC in vertical. Okay, the diff. So force is easy. The position force will apply to CP below C. Okay, and force here FOA. And this distance is delta CP. Delta CP. Okay, so to know the position of the force applied to OA, you have to know where is CP. To find where is CP, you have to know delta CP. With delta CP equal to IC divided by LC area OA. Area OA. Okay. With area OA here, you got it. This one. IC. We have the same shape with the AB is the rectangle, but this one is OA, and this one is 4 meter long. Okay, so IC will be equal to 1/12 of times 4 times OA power 3. Okay, but the difference here is this one, LC. LC, as I said, is a distance from C to pressure is 0 G in OA direction. So LC here, not in vertical. Okay. For AB, LC in vertical, but LC in this case is in OA direction. Okay. So you can find LC depends on the given dimension you have on the question. Okay, data CP. And when you have this one, you can find moment away equal to force away and the distance from O to F away. Okay, it's similar to when you find AB. Okay, and try to do it by yourself. And if you have any question, you can ask me, you can email me. Okay, this one is force on plane surface is very important for the quiz. Okay, so try to do it by yourself. And if you want to practice more, you can have a look this question. Let me see. Let me see. I actually I sent you a multiple choice MCQ on the file on the document last week. Okay, here. Last week, do you remember this question? We have two multiple choice questions. You find question C and you find question E. Okay, and actually we still have one question. In this one, you find the total net force on the whole wall W. Okay, you have to find the force applied to this wall. Okay, this question in the document I sent you last week is this one. Here, this one is what we did last week, 1 and 2. But question 3, you have to find force applied to this wall. This wall I call maybe is Mn. This wall Mn. Force applied to Mn. And this one is force on plane surface. Okay. And you have to here, let me see. Okay, portion 1, 2, 3, 4. Okay, and try to do it and give me the answer next week. Okay, the answer next week 1, 2, 3, 4. Force on this one, total force on this one, and remember that we have in here we have two force from the air and force from water. Okay, because on the top we have air and on the bottom we have water. Okay, so you have to find total force applied to this wall W side 2 meter times 3 meter. Okay, 2 meter high and 3 meter into the space. Okay, we have 4 options here. Okay, so next week give me the answer. Okay, next week give me the answer and try to finish F away and moment away by yourself. And if you have any question, email me. So do you have any question for the tutorial today about pressure variation and force on plane surface? Do you have any question? No? Okay. So remember, finish the MCQ question and next week give me the answer. Yeah, please try to make a group. Try to make the try to find the group member from now, right now. Okay. Try to make it right now. And actually, you have the friends email on UDES Online. You can go to the group on UDES Online to email the friend. Here you have here in the group. if you can't find, and you can email me if you can't find the group, okay, and we try to make a group for you. And yeah, it must from 3 to 5. Minimum is 3 and maximum is 5. Yeah, you can find the friend email in here. Go to the group. This groups. Okay. And this one is summer, lecture summer. Let me see, so many group here. Yeah, lecture. Let me see. Summer 2020, yeah. And you can find the friend email in here. Okay. So firstly, please try to find the group member. And if you can't find it, email me. Okay. Do you have any question? Oh, oh really? 3 to 5 is okay. Group of 3 to 5. Okay. Okay, do you have any question? All right, student. Okay, if you don't have any question, thank you. See you next week. Bye-bye. Bye, thank you. Where's your friend? Just finished. Thank you. Next week, maybe I will